What's going on, everybody? Mr. Spot here. Um, Today is the last new material that you're going to get from me all year long. So that's kind of crazy. That's kind of exciting. So um, we'll get through this here, and then next week the plan is to do a review day on Monday, and then a quiz on a Wednesday, and then you guys are done. You turn in that quiz and I virtually high five you and say you're done. Okay. Please make sure that you get that quiz turned in next week. Okay. I don't want to have to hunt you down at the end of next week. If I don't get that quiz, your grade is going to significantly look different, and that's not good. Okay. For the very most part, everybody's done a very great job this 9 weeks. Let's finish strong and make sure you guys get the grades that you deserve. Okay. I'm going to flip through the homework answers real quick from 12-3. I'm not going to go through each one, so just kind of peek at your answers and pause if you have to. If you have issues with something and you can't figure it out, that's where you need to contact me, or meet me in a conference or something, and we can work one out. Okay. So number 2, it can't be 0. Number 4, the excluded values are 5 and -3. Number 6, the excluded value is d cannot be -6, and simplified, it's just 2d. And go ahead and pause there. You have 11-18. Those are the answers. 13 and 16 are down below because I couldn't fit them there. Okay. All right. Again, if you have any questions, see me in a conference, send me a remind, send me an email. I've seen some people comment on their assignments, asking questions and stuff, and I'm able to answer them there. All right. Okay, so section 12.4, we did adding and subtracting on Monday, and today for the second section, we're going to do multiplying and dividing rational expressions. Okay. So a couple interesting notes here. First, again, the guided notes are on there for you to use if you want them. The rules for multiplying rational expressions are the same as the rules for multiplying fractions. You multiply the numerators and you multiply the denominators. Okay, again, if I have 1/3 times 5/6, I will multiply 1 times 5 and get 5, and I'll multiply 3 times 6 and get 18, and I get an answer. 5/18 is my answer. All I did was multiply 1 times 5, 3 times 6 to multiply those fractions. Okay? You see it again here. If A, B, and C are non-zero polynomials then, so if I have A times A over B times C over D, I would take A times C for the top, and I would take B times D for the bottom. Okay. One other good note is to see the quotient of powers property. Okay. Remember that if there's a situation, there's 2 of them you're actually going to see in this section. We've been talking about one of them, but if I have, if I have x to the 4th over x to the 2nd, remember that it's x over 4 minus 2, which equals x to the 2nd. Also, if I have x to the 4th times x to the 2nd, remember that I do x 4 plus 2 and get x to the 6th that way. Okay, so just remember those 2 properties there. The quotient one is when I'm dividing, I subtract the exponents, and when I'm multiplying, I add the exponents. Okay. All right, one other note before we get started, okay? Let's say that I have a situation where I have 2/3 times 5/6. Now, I could take 2 times 5 and get 10, take 3 times 6 and get 18, And then I would have to simplify that to 5/9. Okay. There's also this strategy called cross canceling. Okay, 2/3 times 5/6. All right, I can't cancel anything with the 3 and the 5, but here with the 2 and the 6, how many times does 2 go into 2? Well, it goes in once. How many times does 2 go into 6? Well, it goes in 3 times. Now, if I cross multiply 1 times 5, I get 5. And 3 times 3, I get 9. It already simplifies it for me. Okay, and I don't have to worry about that last step of simplifying. Now, on easy fractions like that, I understand where it's like, oh, I'll just simplify at the end. But the stuff that we're going to be doing today, I want to encourage you to simplify first. Okay? Simplify first. It will make your life a ton easier. A ton. Okay? All right. All right, here we go. Simplify your answer. Okay. Again, I can look now as the cross cancel. 6 and 7, there's no common factors or anything there. And R and S, nothing I can cancel that way. And same thing, 5S to the third times 3R to the squared. Okay. Nothing that I can cancel there. So from here, I am just going to multiply across. All right. 6 times 3 is 18. And r squared times r squared. That's, again, what I was talking about. R squared times r squared is going to be r2 plus 2, which is r to the 4th. So I'm going to have 18 r to the 4th over 5 times 7 is 35. And s to the 3rd times s is just going to be s to the 4th. Okay? And I end up with my answer there. Check. Can I simplify? I can't simplify the r's and the s's at all. And 18 over 35 does not simplify at all either. So this would be my answer. 18r to the 4th over 35s to the 4th. Okay? All right. These are easy. The reason that these are easy are because all these terms here are just multiplication. It's 6 times r squared. It's 3 times r squared. It's 7 times s. 5 times s to the 3rd. That's a little bit easier, okay? But it's going to get more complicated. All right. Now here, we can cross cancel a little bit, okay? As far as what we can do here, we're going to look at crossing here. All right, let's peek here. I have an 8 and I have a 16. How many times does 8 go into 8? Well, it goes in once. How many times does 8 go into 16? Well, it goes in twice. Okay. These y to the thirds are also going to cancel. So this y to the third cancels, and this y to the third cancels. All right, and I'm left with x squared and then 2. We could do this the other way too. 5. How many times does 5 go into 5? Well, it goes in once. How many times does 10 or 5 go into 10? Well, it goes in twice. Okay? So we've got that. Now, these y's here, this y is going to cancel. And the exponent on this y is going to be canceled, and we're left with just y. And then these z's are also going to cancel each other out. All right. So now what am I left with? Let's write that down first. So I have 1x squared over 1 times 2y over 2. Wow. That is a lot easier to work with right there, if you ask me. Okay. Now I start multiplying across. okay? I'm going to have 2, because 1 times 2, and then I'm going to have x squared y. And then on the bottom, 1 times 2 is 2. And to finish up, I know that my 2's are going to cancel. So I'm left with my answer, which is x squared y. All right, I will be right back. Thumper's going crazy out downstairs. I'll be right back, everybody. All right, sorry about that. I'm back. So we finished up this one here. We did a lot of canceling at the beginning. I know that was really confusing, but in the end, it left us with a very little amount of stuff. We just had to cancel some 2's, and we got x squared y. Okay. Now, these are where they get more complicated. Okay. There are 2 methods for simplifying rational expressions. You can simplify first by dividing out and then multiply the remaining factors, or you can multiply first and then simplify. Using either method will result in the same answer. It will. Okay. My tip to you is, and what I'm going to do throughout all of the notes, is we want to simplify first. That way we deal with smaller numbers and we don't have these huge foiling problems. Like, think about this. If you had to multiply n minus 5 times n squared plus 8n plus 16, you'd have to foil and then 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 foil, and it would be crazy and our heads would be spinning. Okay, so we're not going to do that. But we can simplify first. Now, this one's one of the hardest ones. It's going to be probably the hardest one of the day. So I don't know why I'm starting out with it, but I felt like starting out with it. Okay. Now, you have to treat this and this like a whole term, and this like a whole term. I can't cancel here, okay, because I got a B and a B and then an A and then an A. They would have to be the exact same for me to be able to cancel. Now, down here, I can cancel, okay? So for instance, how many does 2 go into 2? Well, 1 time. How many times does 2 go into 12? 6 times. Okay, this b squared and this b to the third, that's going to cancel. And the exponent, we're going to take 2 of those away and just be left with b. Okay, so I like to then, once I get to this step, I like to kind of organize a little bit. And by organizing, what I do is I like to just write what I have left. Okay, so in this case here, I have 3a squared plus 6a over 6 times b, or 1b. I'm just going to put b over 3ab plus 6b. Okay, so we have that. That really looks like a 6. I promise it's a b. I don't like using b's. That looks more like a 6, I think. Let's see if I don't know how to make it look like a b. Okay, I don't like that at all, but it's okay. All right, so we have that. Now, what can we do with these before we multiply? Because there's still a lot there. Well, let's factor out our GCFs here. Okay, my GCF between 3a squared and 6a is going to be 3a. So down here, if I factor out a 3a, I'm going to be left with a plus 2 over 6 times, I've got my b over, my common factor here is going to be 3b. Okay, so if I factor out my 3b, I'm left with a plus 2. Now, since I have the same term here, this a plus 2 and this a plus 2 cancel out. And all I'm left with now is 3a over 6 times b over 3b. Now, I can really start to simplify now. This is a lot easier to work with, okay? I can multiply across. 3a times b is 3ab. 6 times 3b is 18b. And from here, I can just do a little bit of simplifying. I know that my b and my b are going to cancel. This 3 is going to simplify to a 1, and this 6, or this 18 is going to simplify to a 6. And on this top, I'm left with just a, and on the bottom, I'm left with 6. Oh my goodness. Somehow, we just went from 3a squared plus 6a over 12b squared times 2b to the third over 3ab plus 6b to a over 6. Okay, with a lot of simplifying. Okay? Any questions? I guess I don't know why I said any questions. I just felt like I was at school there for a second. I'm actually going into school today, and I'm like oddly excited about it. It's kind of weird. Okay, that one was hard. No way around it. That one was hard. Okay, go ahead and start this one. And I want you to start this one by trying to factor everything. Okay, find out what multiplies by 16 and adds to get you 8. Factor out your GCF. Find out what multiplies to get you negative 10 that adds to get you negative 3. And I guarantee you'll see the cancellations really quickly, and this one will be a lot easier, okay? Go ahead. All right. Okay, now you should have these all factored out. Let's take a look at it here. First thing you're going to have on this side is just n minus 5. N minus 5, because there's nothing you can simplify there. Over. You can factor out a GCF of an n here, so I'm going to have n times, and then I should have had n plus 4 there, times. What multiplies to get me 16 that adds to get me 8 should have been 4 times 4 and 4 plus 4, so I'm going to have n plus 4 over n plus 4 over what multiplies to get me negative 10 that adds to give me negative 3. You should have had negative 5 and 2. So I should have had n minus 5 and n plus 2. Okay. From here now, there's a lot of things that cancel. This n plus 4 cancels with this n plus 4 here. This n minus 5 cancels with this n minus 5 here. Okay. Once I've canceled, then again, let's write what I have left. Right here I have a 1, nothing I can do there, and an n plus 4. So I have my n plus 4 on top there. And right here I have an n and an n plus 2. Okay, that's my answer. This one's a little bit easier, I'd say. Now, I'll accept this answer. That's fine. If you want to distribute that in, distribute the n to the n and get n squared and then have 2n, I will also accept that. It's kind of your own personal preference there. I don't really care. If you get to here, I'm really happy. All right. I like that problem a lot more. You're very more likely to see that on a quiz. All right. Last one here. This is another one of those ones that you're going to be like, oh my goodness, how did that turn into what we get? Okay. All right. So first thing we want to do, these are all crazy. There's nothing that I can cancel right now. We will eventually, but there's nothing right this second that I can cancel. Okay. Here, though, how many times does 6 go into 6? Once. How many times does 6 go into 12? Twice. This y can cancel, and one of these cancels, so I'm left with just y. Okay? Now, I'm going to try to kill a couple steps here at once. While writing what I have left here, I'm also going to factor out a GCF here. So what's my GCF there? Well, it's 3x. So I have 3x and then x plus 1 over, the only thing that I have left there is a 1, times, on the top here, I just have 2y. And I'm also going to factor out my GCF, which in this case here is 7x and a y. So 7xy. The 7s match up. There's an x in there, and there's a y that they all share. So what do I have left? Well, I have x plus 1 left. Okay? So from here now, I have one thing that's going to cancel, that x plus 1, and that x plus 1 is going to cancel. So if I come down here, let's write what I have left. I have 3x, and I have a 1, times, I have a 2y, and I have a 7xy. Now it's much more reasonable to cross multiply. Okay? 3 and a 2 is going to be 6xy over 7, 1 times 7, and then just xy, because that's what I have left. This now, I'm not done though. This x and that x cancel, and that y cancel, and my answer is just 6 over 7. Wow. We just turned that into that. Okay? So I hope you're starting to see the ins and outs of this one. That one's not as complicated, but it's very important to do this simplifying that I'm doing first. Okay? It's very important. All right. 2 more. The rules for dividing rational expressions are the same as the rules for dividing fractions. To divide by a rational expression, multiply by its reciprocal. Okay, I always joke around that like multiplying by its reciprocal is basically a fancy way of saying the keep, change, flip method. All right, we're going to keep, change, and flip. Okay, so I'll show you here on this first one. I'm going to keep the 2 over g. I'm going to change the division to multiplication, and I'm going to flip the g squared to g squared over g plus 4. Okay, pretty basic. Okay, from there then I'll do a little bit of cancellations. This g will cancel. This will go to just a g, and now I could multiply across, and I'm going to end up with 2g over g plus 4. Again, you have to remember that this is one term and this is one term. They're not like terms, so I can't like cancel that g and that g. Okay, they're different terms, but these are the same and those are the same, so you have to understand that a little bit. Okay, so that's what we get for an answer there. Again, go ahead and pause this video and try B on your own. All right, you're probably looking at me like, Mr. Spot, you really think I can do this? I think most of you can, but let's give it a shot. Okay, first thing I'm going to tell you is we got to clean this up a little bit. Let's rearrange this. This 1 minus n squared, I don't like it. So let's go negative n squared plus 1 over n times, because I'm going to keep, change, and flip. So n squared minus 4n over n minus 1. Okay, now there's some simplifying that needs to go on. This here can be factored, but before it can be factored, we've got to, I'm just going to do it up here for the sake of space. I want to factor out a negative 1. Now I'm left with this n squared, and instead of plus 1, I'm left with minus 1. Okay, now that I've done that, do you recall what n squared minus 1 is? Well, it's a difference of squares. Okay, difference because it's got a negative, and then n squared is a perfect square, n times n, and 1's a perfect square, 1 times 1, even though you might not think it is. Okay, so when I come back over here now, I'll take my negative 1. Now, difference of squares, so I'm going to have n plus 1 and minus 1 over n times. I can factor out a GCF here of n, so I have n, and then n minus 4 over, and then n minus 1. Now, what cancels here? Well, my n minus 1 and my n minus 1 are going to cancel. And my n and my n are going to cancel. And I'm left with my answer, which is negative 1, n plus 1, n minus 4. Now, you could FOIL it. I'm not going to make you FOIL it. Let's just keep it at n plus 1, n minus 4. That's fine. That would be acceptable for me. Okay? That's it, people. That's all you're going to ever hear from me. Okay, you guys are on to bigger and better things in geometry now. Peace out. No, I'm kidding. Okay, you do have an assignment for today. I believe I wrote that it's due on Friday. So I'm going to copy and paste it on here. It is 12.4's assignment is page 882. 1 through 5 odd, 13 through 19 odd, and number 20. Please make sure you pay attention to the odds and evens and don't accidentally do like all of 1 through 5 and all of 13 through 19 and then forget about 20 right there. Make sure you do 20. Okay. Look for me to do a review video on Monday, and then Wednesday I'll post that quiz, and you turn that in, you can say that you're done with Algebra 1 honors for this year. I hope I'll be hoping to make a phone call to everybody here and just kind of saying a final goodbye kind of thing here in the next week or so. So look for that. But other than that, I will see everybody on Monday. Peace out.